Hello and welcome to lesson 9E. I can solve problems using properties and theorems about chords. So our first concept about chords is the congruent arcs theorem. And what it says is that in a circle or in two circles, if my minor arcs are congruent, if and only if the corresponding chords are congruent. So if arc AB is congruent to arc CD, then also segment AB, that chord AB, is congruent to chord CD. And let's talk about why this is true. If I draw in the radii here, well, all of my radii are congruent, and these are opposite, those are congruent angles because our arcs are congruent, right? I create two congruent triangles by the SAS theorem, side angle side. And when I do that by CP/CTC, I can then say that my opposite sides are also congruent. So that means that the two chords would be congruent. There's also a congruent chords theorem. If I've got in a circle or in two congruent circles, two chords are congruent if and only if they are the same distance away from the center. So if XE, if this distance here is congruent to XF, this distance here, notice it's the perpendicular distance because that's the shortest distance between two segments, then we can say that AB is congruent to DC. Those two chords would be congruent. And the reason for this is, once again, I'm going to draw in the radii. Okay. If I know that these pieces are equal, well, all of my radii are equal too, and we know we've got right angles, I create four congruent triangles by the HL theorem, which means then that these pieces of these chords would all be congruent, therefore the chords themselves are congruent. So, moving right along. We also have a perpendicular radius theorem. If a radius bisects a chord and its minor arc, if and only if it is perpendicular to the chord. So if a radius bisects a chord, it's going to do it at a right angle and it's going to split it in half. Okay? So if AB is perpendicular to EX, we know that AE will be congruent to BE. And once again, it's because we're creating lots of congruent triangles. So let's do an example here. I have a circle with a diameter of 20 and a chord located 8 centimeters from the center. So let's draw that as a picture. Here's my circle, okay? And I have a diameter of 20, which means that all the way across, this thing is 20, but I have a chord that's located 8 centimeters from its center. So I'm going to draw in a chord over here. Here's my center, and it is 8 centimeters away. That means this piece right here is 8. I want to find the length of that chord. Well, I can actually do this pretty easily because what ends up happening is this creates a right triangle if I draw in another radius. Now, if the whole diameter is 20, this red segment I just drew in here, it's going to be 10 because it's a radii of the circle. And so now I actually have a right triangle. I'm going to label this little piece right here X, and if this is X, this piece over here is also X. So I would say X squared plus 8 squared is equal to 10 squared. And as I solve this, I am going to get a really nice number. So I get x squared equals 36. So that x is 6. Well, the chord itself is 2 of those x's, right? It's an x here and an x here. So my chord ends up being 12 centimeters long. All right, let's take a look at this guy. An equilateral triangle is inscribed in a circle of radius 8. Find the triangle's side length. Well, what I want to do is I want to draw in a radius. And when I draw in this radius, I'm actually going to draw it in so that it's hitting one of the vertices of my triangle. And I'm also going to draw in one of these perpendicular bisectors. Well, my radius is 8. We know, because we know a lot about equilateral triangles, that each of these vertices is 60 degrees. Which means that this little sliver right here would be 30 degrees. This is 90. So you inadvertently create a 30, 60, 90 triangle when you draw in a radius and it's a perpendicular bisector. So as I'm doing this, I've made these equal. I want to find this side over here. I'm going to call this X, and I'm going to redraw this triangle a little bit larger so we can see it better. This is 30 degrees. This is 8. This is 90. I want to find this side. Because this is a 30-degree angle, we can actually use our special right triangle laws to solve this. Across from 30 is your inside. Across from 90 is your 2 inside, which means this is my in root 3 side across from the 60. So if 8 equals 2n, then 4 must be in, which means this side, which I don't need, is 4, which means that this piece here is 4 square root 3. That means from here to here is 4 root 3. This would be another 4 root 3. So the side length of my triangle is going to be 4 root 3 plus 4 root 3. So my side is really 8 square root 3. And that's my answer. Okay, moving right along. In circle O, the measure of arc RS is 70. And again, guys, that's degrees because it's arc measure. And segment RS is equal to 20. Find the radius of circle O. Well, let's make a picture, shall we? So we have a circle. Boom. And my circle, I have a point R and a point S somewhere on it. This is circle O. And we know that RS, the arc, is 70 degrees, which means this angle here would also be 70 degrees. And we know that from R to S itself is 20. This is 20. Now, I want to find the radius. I'm going to call this guy X. This isn't terribly useful as it is right now, but I can do something kind of cool. I'm going to draw in one of these perpendicular radii that we've been talking about, like this, where this is going to hit this at a right angle, and I've drawn it in to split this angle in half to make this guy now 35 and 35 degrees, okay? And if this whole thing was 20 and I just split it in half, this is now 10. So I'm going to draw this new triangle bigger so we can see it. This is 35 degrees. Still hunting for the radius. This is 10. I can use trig to solve this. In fact, I can use, let's figure out which version of trig. This is the opposite. This is the hypotenuse. So I'm going to use sine. I'm going to say sine of 35 is equal to the opposite side, which is 10, of the hypotenuse, which is x. I multiply both sides by x to solve. So I have x sine of 35 is equal to 10. Divide by sine of 35, I get x equals 10 divided by the sine of 35. And I'm going to plug that into my calculator, which you can see I've done already. 10 over the sine of 35 is 17.4345. I want to 3 decimal places. X equals 17.435 units. And that's the radius. All right, guys, we're at the end of the notes. I want you all to take a look at the MML. If you have any questions, please ask. But thank you guys very much for watching.